Okay, as I said previously, there are two versions. There's version A and there's version B. The only thing different is the front page. After that, they are all version A. So you can only tell what version you have by looking at the front page. Here are the correct answers. I'll give you the letters first and then I'll do an explanation. If you have version A, the correct answers are B, A, B, and D. B, A, B, and D. If you have version B, the correct answers are, oddly enough, B, A, D, and then B. Different order of questions, and it just happened to be almost identical code. B, A, D, B. Okay, so if you have version A, the first question is, blank is the study of why objects move as they do and the forces that cause the motion. The correct answer is dynamics, B. Dynamics B, and I think that is question number 2, if I'm not mistaken, on the next verse, right? So the answer, and I don't know what, I guess that would be A. It is dynamics, and I can show you where if you want. It's in a description on the very first handout we did. When you convert from 70 to 70 kilometers per hour, you should get 19.44, which is A. If you have the version B, I think it's question number 4, and the answer is B. And Kaylee, I did change your mark for it. Question number 3, given the position time graph, and it's a curvy kind of one. This is sort of ticker tape motion in a bit of a sense. That one is B, positive velocity, positive acceleration. How do I know it's positive velocity? Oh, it's not. No, sorry. It's negative velocity, right? Negative velocity, positive acceleration. How do I know it's negative velocity? Because the slope is negative. And how do I know it's positive acceleration? Because it's getting flatter, which means it's slowing down, which means the signs have to be opposite. Did I? Okay. I'll come back and I'll. If you've got version B, I don't know which question that is. Is it also number 3? It looks like, right? Also number 3, and the answer is D. The last question is, given the velocity time graph, what type of motion is this? It's a flat line. So because it's velocity time, it is constant velocity, isn't it? Yeah. Velocity remains the same. So constant velocity means that the acceleration is 0, and because it's above, it's positive. So it's positive velocity, no acceleration, which is answer D on version A. And if it's version B, Zach, the flat line one, what's the correct answer?
B.
B?
Velocity, no acceleration.
Okay. Okay. When you flip the page, everyone has exactly the same test. I won't always do this. It just makes it easier on certain tests. Okay? What is a frame of reference? Give an example. So I'm looking for something like, it is the point where you measure position from, the point where you measure velocity from. It's an arbitrary starting point to make a reference or a measurement, something like that. Just saying arbitrary starting point kind of implies to me that you're just writing down what you were told and you have no idea what that actually means. So be aware. I'm looking for more. You have to sell me that you know what you're doing. Stop trying to save ink or pencil lead by saving a few keystrokes or pen strokes. Okay? Write down everything you know. What 3 things must be present to give an object position? Several people used circular logic and said that one of the 3 things to give an object position is its position. Doesn't make sense, right? 3 other things. An object's position is defined as an origin or frame of reference, the distance from that origin or frame of reference, and the direction from that frame of reference. Origin, distance, and direction are the 3 that I'm looking for. And that is on one of those very first handouts. What is variable motion? Okay. English is important, you guys. Write in a sentence. Don't just say something like, where it changes. Where what changes? Diaper changes? I don't know what you're talking about. You can't use the word it. What is it? Okay, variable motion is motion where the velocity changes. motion where the velocity changes. And I have to make a subjective judgment call as to how much you know, depending on what you write. The more you write, the better chance I know what you know. Okay? Don't just try to scribble it down and get done early. Give an example, things like a car accelerating, speeding up, slowing down, balls falling in the air, balls rising, basically anything where the velocity is changing. And the corresponding VT graph could really, I was looking for this, but I accepted that. I even accepted this because technically that's true, although when you do this, that tells me you don't know the difference between position time and velocity time. I get worried, and I think to myself, oh, I should have worded that a little bit better. Okay, so that was 3 marks there. Okay, flip the page. Number 8. Remember I said the number one thing you need to figure out is what kind of graph are we dealing with? This is a position time graph. To find delta D from 0 to 3 seconds, your graph looks like this, doesn't it? Okay, so from 0 to 3 seconds, we're talking about this. Delta D, the displacement. So you simply read them off the graph, and that's going to be minus 6 minus 0, which is minus 6. Minus 6 what? Meters. Are units important? Zach, would you like 50? 50 smacks in the head? Adam, would you like 50? You wouldn't like 50 bucks? Too bad. Units are important. Units are important. I've been planning that one for a while. Thanks for playing along, Adam. It's like we planned it. It's like I said to you in the hallway, hey, when you... Well done. Well done. Units are important. Part B, V bar from 3 to 5. 3 to 5 is this part right here. Velocity on a position time graph is the slope. And so you go and find the slope. This point right here is at 5,6, I think. No, 5,8, right? And this point down here is at 3, minus 6. So it's going to be 8 subtract minus 6, subtract the y's, all over, subtract the x's. 5 minus 3, so that's going to be 14 over 2, which is 7. 7 meters per second. I'm warning you right now, there will be a mark for units on the next test. Get used to putting units down. They're important. I tried to circle every time you made a mistake with your units. Part C. V bar from, V inst at 7 seconds. You're looking for the instantaneous slope. The slope is flat. All you need to write is 0. Do you need to show work for that?
No.
You can if you want. I think I can let this slide. It's obvious that it's flat. When is this object moving to the right? When the slope is positive. When is the slope positive? From 3 to 5 seconds. Only that interval is it moving to the right. 4 marks. Question number 9. The only difference here, it's a position time graph. The only difference is it's curvy. Right? It's curvy. Delta D from 0 to 10. This one caused a ton of grief. This point right here is 10, 5. So what is the final position? 5. What's the initial position? 0. It's 5 minus 0, or 5 meters. At 10 seconds. That's all you do. It clearly says position time graph. I tried to warn you guys. Details are important. V bar from 0 to 10. So in fact, you are finding the slope of that line. So it's actually a displacement of 5 over 10 seconds, 0.5 meters per second. C, V inst at 7 seconds. You're looking for instantaneous slope. The first thing I'd look for is a tangent line. If there's no tangent line, I don't even look any farther. It's wrong. You don't know what you're doing. I don't care if your number is even close to mine. Yes.
So undefined.
It's not undefined. The slope is approximately 0.7 meters per second when you find the slope. Okay? Around 0.7. But you've got to have that tangent line. And what kind of motion is this? This is known as
Variable.
variable motion. Uniform is when the velocity stays the same. Okay, number 10. Number 10 is worth 11 marks. Will you see a question like this on the exam? Absolutely. Rock solid guarantee. Okay, graph looks like this, right? A bar from 3 to 5 seconds. We are talking about the slope from 3 to 5 seconds. Oh, the slope is 0. And its acceleration, so it's 0 meters per second squared. Acceleration is meters per second squared. You must have the proper unit. You've been warned. B. When you don't have the proper units, it kind of implies to me that you don't understand the difference. And that comes into play when I'm reading, when I'm trying to make a judgment call later. I look for things like that. A bar from 11 to 15. 11 to 15, I think, is this part here, right? So again, it's a slope thing. So it's going to be 2 minus a minus 2 all over 15 minus 11, which is 4 over 4, which is 1 meter per second squared. Right? You're just finding the slope there. C, delta D from 0 to 8. Do you notice that it's worth 3 marks? I kind of don't like the fact that I'm supposed to give you that because it sort of gives it away. Can I help you, Miss Ocean?
Yes.
Okay, don't get distracted. A little break there. Part C, delta D from 0 to 8. Oh yes, I was saying 3 marks, which means there's a good chance it's going to be 3 parts. And the parts are triangle, rectangle. I guess it only goes to there, right? Triangle. And those values are 3 plus 10 plus 6 for a total of 19 meters. Not meters per second, it's displacement. Meters. D, A bar from 0 to 8. Now 0 to 8 is from here to here. This one, you don't have to draw the line, but you can. It helps me understand what you're doing. And the answer there is the slope. So that's going to be 6 over 8 because it goes from 0 to 6, right? And 8 minus 0. 6 over 8, exactly 0.75 meters per second squared.
Where's the 6?
This point right here is 6, 8. Oh, I got that right? No, it's backwards. 8, 6. Right? So what's the change in the y, Josh? Goes from 0 to 8?
8, 6.
Yes, 8, 6. It's the slope. Will you have to find slope again in the future?
Oh, that is.
Yes! You have to know how to calculate slope. It's like saying I'm a pretty good driver, I just don't do left turns very well. You gotta do left turns. E. A inst at 13 seconds. Again, I'm looking for a tangent. I'm looking for a tangent, and that value is approximately 1 meter per second squared. And you would have to show the work. F is V inst at 12 seconds. You're simply going to read it off the graph. right? Because it's a velocity time graph. You're going to read it off the graph. Part G is displacement again, which means find the area. We're talking about this triangle and this one. And lots of people shaded correctly, but they forgot that when it's below that the value is negative. And so you get, and you have to estimate that point too, right? You got to kind of guess at what that point is. A lot of people guessed really poorly. Like they called it 3 and it's not 3 at all. Or they called it 2. It's like crossing at about 10.3 or 10.2, is it not? Okay, so I got the upper one is about 6.9 and the bottom one is about minus 0.7. Why minus? Because it's below. So you get about 6.2 meters. About. If you got anything more than 7, then I knew that you forgot to subtract. About 6.2 meters. Jaden has a question. All right. Okay. Question number 11. Likely the hardest question on the test. Will you see it again on the exam?
Yeah.
Yep. We did ones kind of like this. We did. You got to think. This one is truly a thinking one. There was a few people that got their displacement and their velocity time mixed up again. Alex Trebek in the house. Displacement time. So, in fact, you know what? I even remember saying, maybe that was the other class. I'm pretty sure I mentioned this question. A boy is riding a motorbike at a constant speed along a gravel road. So the displacement time graph is straight. Straight. And then he approaches the intersection and slows down and does the country stop. So it flattens out. And then he goes back to the same speed he was at before. And then at the next one he stops, so it gets flat. A lot of people got that right. Okay? The velocity time graph. You're graphing the slope. The slope here is constant and positive. And then it dips down because he slows down, and then he goes back to the same speed as before, and then the next time he comes to a stop. Okay? And a lot of people get like 3 out of 6 on this. The acceleration time graph is the hardest one on the whole test. But it's the same thought process. What's the slope right here? 0. And then right there it becomes negative for a tiny fraction of time. Then it goes back to 0. The slope becomes 0. And now the slope becomes positive for a brief period of time, and then it goes back to 0. And then it becomes negative for a longer period of time, and then it eventually goes back to 0. You're graphing. This is the slope of this one. And the velocity time graph is the slope of the one before that, exactly. Any questions about that one? I got to pick up the pace so I can get done in time, guys. Number 12. Okay, number 12 is a judgment call. I'm really trying to find out, does this student understand acceleration? And I have to look at a whole bunch of different things. First of all, you have this, right, to fill in. Now, a lot of people get this right, 0, 3, 6, 9. But to be truly correct, I would like to see these units. So if you don't have meters per second, if you have meters per second squared, or meters, evidence for me that you don't quite get the difference. So then I move on to the explanation part, right? And I'm looking for something like, it means each second the velocity increases by 3 meters per second. Again, the units are important. If you write it increases by 3 meters per second squared, it doesn't make sense. More evidence that you don't quite get it. If you tell me that it goes 3 meters every second, that really worries me because 3 meters every second is known as the speed. And now that is very good evidence that you don't get the difference. So it's a judgment call out of 2. And I look at the whole page and make a judgment call. The units are important.
So like if you said like it's increasing 3 meters every second.
If you said it increases by 3 meters per second every second, yeah, that almost sounds like you're hedging your bets and you're trying to put it either way, and so you can argue it either way. That's what that sounds like to me.
That's not we're keen to bowl.
Number 13, the bowling ball. Okay. Are formulas important?
Oh, extremely important.
I didn't subtract 1 mark off anyone for formulas, but I spent time writing show the formulas on about everyone's. When we get to the last unit, and there are, and I'm not lying, 6-step problems, you better have the formulas. You better have them. Stop being lazy. Write the formulas. I write the formulas on everyone's test for you. Like when you don't do it, right? So you can't tell me that it's a waste of time. What's a waste of time is if I write it and then you don't do it. That's a waste of my time. Don't do that to me. Write the formulas. Okay. So we've got a bowling ball leaving the hand of a bowler at 2.2 meters per second. When it reaches the pins 2.6 seconds later, it's traveling at 1.7. What is its acceleration? So the first thing you do is you write acceleration as delta v over delta t, and then you realize I don't have the change in velocity. So then you just grab this formula and you move it over here. Oh, what's that you say you can't do that? Use a pencil, Jaden.
You can't really pick it up very well, you can, like,
Use a pencil. You can erase it and then do the first step first. Okay? Or think ahead a little bit and don't write it first. Okay? So you need to write delta V is final minus initial. The final speed is 1.7. The initial speed is 2.2. And you divide by, oh no, hang on. And you get an answer of minus 0.5. That, my friends, is the change in velocity. That's what goes over here. Minus 0.5 over 2.6 seconds. So A is equal to minus 0.19 meters per second squared.
So would it be like alright if I put like A equals delta V over delta T, and then underneath I put A equals
You can combine them, yeah.
CF?
Yeah, that's fine. Yeah. Yeah, you're just taking this and you're plugging it. Yeah. No problem. Okay? This is what I expect to see. Okay? I don't like this stuff, you guys. Where people do their, or like they do this, right? Like, where's the answer? But I see this sort of stuff. It's crazy. No, put it in order. You are trying to convince me you know what you're doing. Question number 14. How long in seconds does it take a car to accelerate from rest to 55 at 2.2? The first thing you have to do is take that 55 and divide by 3.6. And you get 15.3. It's another chance to show me you know how to do that. 15.3 meters per second. The final velocity is that 15.3. The initial velocity is 0. Now, could we just go to A equals delta P over delta T here and just go 15.3 over, oh no, we're looking for time, right? 2.2. Is this acceptable?
Yeah.
Yes. I'm okay with this, bending the rules a little bit, right? Do you always have to do the subtract 0 thing? You should, but at some point you realize, oh my God, do I have to do this again? I know it's 15.3. Okay? Now, here's where there were some problems. You have to be able to solve this, you guys. There should be no question at all about how to solve this. This has to be automatic. You've learned this a long time ago. You just divide. I had several people do multiplication here. No. These switch and becomes divide. Okay? If you need extra help with the actual solving part, please ask. I'll try not to be frustrated when you ask me for help. 6.9 seconds. Probably because you showed your work. Did you show this? Did you get this far, Josh? Did you show this work? And then you just didn't know how to solve it properly? Yeah, so I gave you a half for this. Again, that's a benefit of showing your work, right? You're convincing me you know something. Okay, now in 15, I explicitly ask for the VF. A ball is dropped from a cliff. The acceleration due to gravity is minus 9.8. The ball lands after 6 seconds. What is its final velocity, VF, when it lands? Yeah? The acceleration is minus 9.8. You're solving for the change in velocity. The time is 6. Multiply. You get delta V is 58.8. Actually negative. Right? It specifically asks for the VF. Now, is the VI 0? Sure it is. That just means the math is easy.
0 plus 0. No. You know what? This answer is so easy. That's because the other
Number 16, a drag racer has an average speed of 135. How many seconds does it take to cover the 150-meter track? You have to take that 135, divide by 3.6, and get 37.5. And then it's simply V bar equals D over T. The average speed is 37.5. D over T. Once again, it's a divide by. You got to be able to do this, you guys. Oh, I haven't been recording. I wonder how long I've been doing that. Don't worry about it. Everyone's here. Okay. Have your analysis sheet stapled to that. You can just leave it on the table. I'll pick it up in a minute because I still got a couple people to write. Unfortunately, you'll get them back shortly. For me? Well, this is what we're doing next. Dynamics. So it's the force part of things moving. Okay? So here's what you're going to have to do. Identify the 4 fundamental forces of nature. I will give you those in note form very soon. Perform an experiment to demonstrate Newton's second law. You can't get credit for this until you do that. It says in the curriculum, this is what the Manitoba government says I must do. So you have to do that. Perform an experiment. Define the unit of forces to Newton. I mentioned this before. I interpret that as puts the letter N at the end of force problems. Knows that the unit of force is the Newton. Define F net as the vector sum of all forces acting on a body. You thought vectors were over, didn't you? They're back. Vectors, part 2. The sequel. Yep. Okay, and that will include the force of friction, normal force, gravitational force, and applied forces. We will construct free body diagrams to determine the net force for objects in various situations, including balanced and unbalanced forces and inclined planes. Inclined planes are fancy words for ramps. And solve problems using Newton's second law and the kinematics equations that we just finished using. So it's a do-over. Every unit just gets, it's like the Matryoshka dolls.
Oh, yeah.
Would you say that every unit has to go harder then?
Yep, I would.
Yay.
Having said that, when you look back at the previous ones, it's like, that was easy, right? That's called the exam. Okay, now I provided for you, stay with me you guys, I know you're not used to working right to the valve. It's different today. Okay, stay with me. I provided for you the problem types. You're going to see forces, horizontal forces with friction, so objects like this. Forces at an angle like this, like if you're like pulling along a sled or pushing a lawnmower at an angle. And there will also be perpendicular forces with and without friction. So how do you add those forces? Well, they are vectors, aren't they? And you're going to add them tip to tail. You mispronounced it. It's pronounced hooray.
No, it's not.
Hooray! Hooray for vectors.
It's not.
Okay, now, in the interest of trying to get caught up, here's what I'm going to do. You don't have to write this down. Okay? You do not have to write this down. Where is it? You do not have to write this down. I'm about to. You do not have to write this down. These are the 4 fundamental forces. They'll put the fun in fundamental. Don't ever fall for that. Because usually there's no fun involved. Okay, now when I say fundamental, what do I mean? I know I've only got 5 minutes. What do I mean? No.
Main.
Most important, it's like the building blocks. It's the foundation. Okay, there are only 4 fundamental forces, and every other force is sort of like a child or an offspring of those forces. Okay, and here they are. They are gravitational force. It's an attractive force. I like it. I'm attracted to the Earth. And it exists between 2 objects. Any 2 objects. I used to put people on the spot. I'm not going to do that anymore. I'm about to say this. I am attracted to my pencil sharpener. And conveniently enough, the pencil sharpener is attracted to me. However, at the same time, I am attracted to my computer over there. And it's attracted to me. Yes. And I'm attracted to my cable right here. Vice versa. Yes, I know. I get around in the gravity world. Okay. I've got to go through all this, you guys. Give me just. Okay. Gravitational force between the center of the Earth and objects near it causes objects to fall toward the surface of the Earth, right? And this is known as a gravitational field, which oddly enough takes up a whole unit next time, real soon. We're going to talk about gravity a whole lot more. Don't let it get you down. Cool.
I see what you did there.
You like that? One of my favorites. The second fundamental force is electromagnetic force. It's what holds matter together. It's what really matters. Pretty much, yeah. Right? It holds you together, you guys. It provides the force that binds atoms into molecules. Okay? It is the force between particles of opposite charge, which is attractive. It's a good looking force, again. And if they are similar charge, then that force is repulsive. Ooh. Right? It's what holds stuff together. The electromagnetic force. Don't write this down. The third one. Oh, before I get to the third one, I asked the question. If like charges repel each other, just stay with me, you guys. I know it's almost done. The bell hasn't gone. I can still teach. Okay? If I look randomly at my periodic table and I pick carbon, carbon is atomic number 6. That means it has 6 protons in the nucleus.
Yeah.
All these positive protons in there not liking each other. Get away, right? What's holding that atom together? The strong nuclear force. The strong nuclear force that holds protons and neutrons together in the atomic nuclei. It is the strongest of all forces. Hence the name strong nuclear force. Stay with me. It acts only over extremely short distances. So small, you can't even really realize it. Okay, there's one last one. It is called the weak nuclear force. The weak nuclear force. This one is responsible for such kinds of radioactive decay, such as the decay that creates radon gas. Does anyone know what radon gas is? Radon gas is a radioactive gas. It is in all of your homes. It is particularly prevalent in Canada, even more so in Manitoba, and of all of Manitoba, the worst place is the Parkland region. We all have it in our homes. I hate to tell you this, it causes lung cancer. It's the second leading cause of lung cancer in Canada. Even worse if you happen to be a smoker. No, I'm not saying that. There are ways. Hang on. I know the bell's going to go right away. Just hang on. Listen. There are ways that you can fix it. It's basically a radioactive gas that comes up through your basement. You just have to do your basement and create some ventilation. Okay, so there are ways to fix it. Next time, don't run away even if the bell goes. Next time, what I need you to know is the names of the 4 have some vague idea of what they're about, and you need to be able to write them from strongest to weakest, which I will go through. Hang on, don't run away. I'm going to post those notes to Schoology. If you want them, you get them. If you don't care, well, that's up to you.
No, it's all